Good evening. I am Soumapnag, a research scholar at School of Mathematics and Statistics, University of Hyderabad. So today I will solve problems from partial differential equations of assignment 12 of previous year. So let me first show you the questions. Questions are from question number 7. Question number 7 is that required zoom it. Question number 7 is that the problem is about solving the heat equation by the method of separation of variables. So I separation of variable method I have to use to solve this uh, heat equation. The question is that consider the following initial boundary value problem: ut minus uxx is 0, where x comma t lies in open 0 1 crosses 0 infinity, u0 t is 1, ux 1 comma t is 1, and initially ux comma 0 is 4 sine 5 pi x by 4 to cos square. Hello, is the screen visible? Hello, can you hear me? Anjana Mohanta, can you hear me? And is the screen visible?
Yes, sir. Yes, sir.
Okay, so I am solving the problem number 7. Okay, it is given that the problem is about solving the heat equation by the method of separation of variables. So the boundary value problem is ut minus uxx is 0 when x comma t lies in open 0 1 cross 0 infinity, u0 t is 1, ux 1 t is 1. That is, one condition is Dirichlet and one condition is Neumann boundary condition. And initially ux comma 0 is 4 sine 5 pi x by 4 into cos square 5 pi x by 8 minus 2 sine 5 pi x by 4 plus x plus 1. X lies in 0 1 open interval. Now the question is, if u is the solution of the above initial boundary value problem, then which one of the following is the initial boundary value problem satisfied by w, where w is given by wxt equal to uxt minus x minus 1. So let me first write the equation for u, then I will solve for w. So question number 7 is that the heat equation for u is given by ut minus uxx is 0 when x comma t lies in open 0 1 cross 0 infinity, and with the conditions are given by u 0 comma t is 1 and ux at 1 comma t is again 1, where t is positive, and initially when t equal to 0 ux comma 0 is 4 sine 5 pi x by 4 cos square 5 pi x by 8 minus 2 sine 5 pi x by 4 plus x plus 1 when x belongs to open interval 0 and 1. So what you have to find, let me show you the question again. You have to find that w is given by w equal to u minus x minus 1. and we have to find the equation which w satisfies. So let me write expression for w, that is define w x comma t as u x t minus x minus 1. That is defining. Now we have to find the equation for w. So what is w of t? Can you tell me? The derivative with partial derivative with respect to t. What is that? Can you tell me? Otherwise, I will tell. No, no hesitation. Hello, hello. Okay. So actually, Wt is same. Wt is just derivative with respect to the t. That means derivative of u with respect to t minus derivative of x with respect to t and derivative of 1. But derivative of u with respect to t is ut. But what is derivative of x with respect to t is 0, and other 1 derivative of 1 with respect to t is also 0. So Wt is same as ut. And what is w of x? Wx is ux minus 1, derivative of x with respect to x partially, that is 1. Okay, and wxx is uxx, derivative of 1 with respect to x is 0. So what the equation w satisfies? So w, if I replace the equation for u is ut minus uxx equal to 0. So equation for w is wx comma t is, only replace u t by wt and uxx by wxx, that is, so wt minus wxx equal to 0 when x comma t lies between 0 1 cross 0 infinity. So now the what are the boundary conditions for w? Now w 0 comma t is that w0 comma t is what? u0t. I am putting x equal to 0 minus 0 minus 1. So now u0t is given in the question. u0t is 1. So that is 1 minus 1. 1 minus 1. So w0t is 0. And another boundary condition is wx1t, that is same as ux1t minus 1, because wx equal to ux minus 1. So what is ux1t in the question? It is given that ux1t equal to 1. So that is 1 minus 1 equal to 0. So both boundary conditions are 0. Initially, now initial condition is at t equal to 0. Wx comma 0 is ux comma 0. I am putting t equal to 0 in this defined definition. Wx comma 0 is ux 0 minus x minus 1. So let me write, an initial condition is w x comma 0, that is equal to ux comma 0 minus x minus 1. Ux comma 0 is given in the question, that is 4 into sinus 5 pi over 4, this expression. So let me write, that is 4 sin 5 pi x by 4 cos square 5 pi x by 8 minus 2 sin 5 pi x by 4 plus x plus 1. This is ux comma 0, and there with us wx comma 0 is ux comma 0 minus x minus 1. So this x and 1 are cancel out. So what I got is that the only term involving sine and cos and their squares minus 2 sine 5 by x by 4. This is I got. This is doubly satisfied. So let me again show you the questions. What are the answers? So what is W? W satisfies Wt minus Wxx equal to 0 with both the boundary condition equal to 0. So option A is false. Option B is Wt minus 1 minus false. Option C is Wt minus Wxx is 0 and W0t is 0. Wx1 comma t is 0. It is true. And what is that should be W. Wx comma 0 is uh, 4 sine 4 sine this thing plus 2x plus 2 no. So option is correct option is option D because w0t is 0, wx1t is 0 and wx comma 0 is 4 sine 5 pi x by 4 cos square 5 pi x by 8 minus 2 sine 5 pi x by 4. The rest of the term cancel out that I show you. Wx comma 0 is the same thing. So the correct option is option D. The is the answer is option D. Okay. Okay. So this completes the question number 7. This is just a transformation. We have to transform u by w. Hello. Is the screen visible? Is the screen visible? Can you please confirm? Sudeshna Maiti. Hello. Can you hear me? You can type in chat box also. Yeah. You raise a hand. Yes. What is your query? Is my screen visible? Okay. Fine. Fine. So actually, I am again then tell you what I have solved. I just solved question number 7 that is visible is that given that u satisfies the heat equation that ut minus uxx equal to 0 and boundary condition is u0 comma t is 1 and ux1 t is 1 and ux comma 0 initially is this expression involving sine and cos and x and 1. Okay, 4 sine 5 pi x by 4 cos square 5 pi x by 8 minus 2 sine 5 pi x by 4 plus x plus 1. So what the question number 7 tells that you have to find they are giving some transformation that is you be the solution of this above problem, then which one of the following is the initial boundary value problem satisfies by w, where w satisfies wxt equal to uxt minus x minus 1. So what I did is that I wrote the equation for u first. Now w is defined by uxt minus x minus 1. Okay, so what is w of t? Wt means partial derivative of w with respect to t, that is same as ut minus this is x and 1, so this derivative with respect to t are 0, so that is wt is ut. Now what is wx? Wx is ux minus derivative of x with respect to x, that is 1, and wxx is again partially derivative with respect to x, that is same as uxx. So my equation for u is ut minus uxx is equal to 0. Now I got ut equal to wt and uxx equal to wxx. So my equation changes to wt minus wxx equal to 0. Region is same. X comma t belongs to open 0 1 cross open 0 infinity. Now the boundary condition. Boundary condition is u0t are given 1 and ux1t is 1. Now here what is w0t? I am just replace x by 0, that is u0t minus 0 minus 1. So that is u0t is given as 1, so 1 minus 1 0. And what is wx1t? Wx1t is ux1t minus 1 and ux1t is given as 1 in the question. So wx1t becomes 0. Now initially wx comma 0, that is I have to put t equal to 0. So wx comma 0 is ux comma 0 minus x minus 1. Here I am defining w. So wx I am putting t equal to 0. So wx comma 0 is ux comma 0 minus x minus 1. So ux comma 0 is given as this expression, the initial condition, and this expression is I wrote here, and minus x minus 1. So this x plus 1 and x minus 1 cancel out. So I got this answer. So let me show you the question. Question is you have to find the equation for w and the condition. So it matches with option 4. Okay. This is just a simple calculation, simple transformation. Is this clear to you? Is this clear to you? Or you have any question? Hello? It, you have no question. Is that it? Okay. So I will move to next question then. Okay, fine. So the next question is question number 8, that is which one of the following is the solution of the initial boundary value problem for W defined in the previous question. That is here. This is the answer. So here W is given by this heat equation satisfying W2 minus Wxx equal to 0, and you have to find the solution for W. So you have to use the method of separation of variable. So you know how to deal with this, or I will directly write the solution then. So number 8. What is the solution by the method of separation of variable? What is the general solution? Can you tell me what is, or you have any idea what is general solution by method of separation of variable for this type of equation, the homogeneous heat equation? What is the type of the solution? Anything? If you tell, otherwise I will tell. No, no need to worry. Yes, Sudeshna Maiti. Otherwise I will tell. No, no hesitation. Okay, okay, I will tell. No problem. So actually you have to use method of separation of variable means you have to use like wxt separation. So function of x, sorry, uh, function of x into function of t. You have to take like this. Now you put in this equation, you got what is wx. Wx6 is tax is t of t, right? Just differentiation with respect to x. Wxx is x double prime x into t of t. So, and wt is x x t dash t, because I am differentiating with respect to t. So if I replace this thing, all this thing in the my equation for w, I got that x x into t dash t of t minus x double prime x to t of t equal to 0, right? So what I got is that, okay, let me go to next page. I got like this. So I am just separate. I am changing the x double prime x equal to t of t by t prime of t. Left hand side is a ratio of function of x and right hand side is a ratio of function of t, and both are equal. When it will happen? It will happen when both the ratios are equal to a real constant lambda. When lambda belongs to R. Because left hand side is a function of x, and right hand side is a function of t. X and t are independent variable, but they are equal. This is only possible when they are both equal to constant, the ratio equal to constant. So now you have to solve these two equations. You have to solve, okay, let me write it 1 by lambda so that no confusion with the general case. The same thing, I'm just interchanging equal to lambda, I'm saying. Okay, so you have to solve these two equations, x double prime x minus lambda x equal to 0 and t prime of t minus lambda t equal to 0. Okay, so what you got finally is the solution for u, for w, that is wxt. You got as summation. You have to find eigenvalues and etc. thing that you can find in the lectures. You got like this function xn is t and t, where n minus from n equal to 1 to infinity. This is the method of separation of variable. So we got is that we got like this type of function: am sine 2n minus 1 by x by 2 into exponential. Exponential means e power n minus 1 whole square pi square by gamma pi square t by pi square t by 4. Okay, so I got like this. This is the general solution for w. For you can find this in the lecture videos of set. Okay, so this is w. Now what my initial condition is, w x comma 0 is this. So I will put t equal to 0. W x comma 0, I have this 4 sine 5 pi x by 4 cos square 5 pi x by 8 minus 2 sine 5 pi x by 4. So I am putting t equal to 0. So W x comma 0 is summation equal to 1 to a n sine 2n minus 1 pi x by 2 into exponential of 0 is 1. Okay, if exponential means e power. I am putting t equal to 0, so exponential 0 I am writing. Next line I will write exponential 0 equal to 1. So I got a n, only a n sine 2n minus 1 pi x by 2. Okay, up to this, is it clear for you? Up to this, is it clear? WXT, and I'm putting the, I'm finding genuine solution. I got W. Okay, you wrote something. Okay, fine. So I found Wx comma 0 in terms of series. Now what I have in my hand is that Wx comma 0 is given by this this line. I'm putting it right, this line. So Wx comma 0 is 4 sine this expression. So I have to compare this thing. Now here I got Wx comma 0 in terms of series. So I have to find the value of an, or for which an I got non-zero solution. So Wx comma 0 is the expression is, okay, let me write it separately. So now Wx comma 0 is 4 sine 5 pi x by 4 cos square 5 pi x by 8 minus 2 sine 5 pi x by 4. Now I will simplify this expression. That means I took common sine 2 sine 5 pi x by 4. I am taking common, that is I got 2 cos square 5 pi x by 8 minus 1. Okay, so 2 cos square theta minus 1 is, okay, okay, sorry, let me just check once. Okay, so 2 cos square cos 2 theta. So 2 cos square theta minus 1 is cos 2 theta. So I will write 2 sine 5 pi into cos 2 into 5 pi x by 8, that is 5 pi x by 4. Now 2 sine theta cos theta means sine 2 theta. So sine 2 into 5 pi x by 4, that is 5 pi x by 2. That I got for simplifying. So I move to the next page. So what I got is that Wx comma 0 is sine 5 pi x by 2, which is equal to this series summation n this. Now you have to find n. So what I got, so we get right, summation equal to 1 to infinity an sine 2n minus 1 pi x by 2 equal to what I got, Wx comma 0 is sine 5 pi x by 2. So now can you tell me anything about this n? How can we find anything? Otherwise I will tell. Can you tell me from this expression what is how can I find an? Yes. Okay. Can you tell me how can I find an from this? Okay, you wrote something. Sorry. Okay, no problem. I will tell. Actually, Fourier series, right? Fourier coefficients. So this is Fourier sine series. So we have to find n as the Fourier coefficients. That I will tell you. N is that n equal to Fourier coefficient, that is 2 by length of the interval. Length of the interval is 0 1. Here my x function of x, everything is function of x. So my x interval is 0 to 1, right? where I wrote here x comma t lies between 0 1 cross 0 infinity. So x lies in 0 1. So 2 by length of the interval is 1, 2 by 1 integral lower limit is 0, lower limit to upper limit into what is in the right hand side sine 5 pi x by 4, sine 5 pi x by 4 into sine into this term what is with the n, all these things, sine 5 pi x by 4 into sine 2n minus 1 pi x by 2. I sorry, this is 2 sine 5 pi by 2 in the right hand side. So 2 minus 1 5 pi by 2 dx. This is n. Now this is an integration you have to solve. So you know anything about orthonormal property of sine? Anything? Otherwise I will tell. Just you tell if you know or not. Some orthogonal property of sine function or orthonormal property of sine. That is what will be the this sine uh, m pi x into sine n pi x dx, this integral from say 0 to 1, or m pi x by 2 or n pi x by 2, this type of integral 0 to 1 dx equal to what happened one to some cases when m not equal to n, when m equal to n, what is the values, you know anything, anything this type of property of sine function, you know or not, can you tell anything? Okay, okay, I will tell. No, I told. Uh, Let me just clean this. Okay, so sine has the orthonormal property. That means sine function with its sine function equal to this integral equal to 1 when this m and n are equal. Okay, I just erase this thing. Okay, so I will write it here. That is 2 by 1 is 2 integral 0 to 1 sine 5, sorry, sine 5 pi x by 2 into sine 2n minus 1 pi x by 2 dx. Okay, so this sine function has orthonormal property, that is sine m pi x by 2 into sine n pi x by 2, this integral 0 to 1 dx, this is equal to 1 when m equal to n. Okay, when m equal to n, that you can prove easily. You put m equal to n, then uh, multiply with half and 2 both sides, then you can get the answer. And 0 when m not equal to n. So here for every n except n equal to 3, because 2n minus 2 into 3 minus 1 is 5. So in my case, uh, let me write it here as a property. So in my case, only it will non-zero n. So here n will be non-zero. That is n will be non-zero when my 2n minus 1 equal to 5. That is n equal to 6 by 2. That is 3. So when n equal to 3, we only get non-zero. So what is the value for that? So a3. We have to write a3, right? a3 means 2 by 1 integral 0 to 1. I am putting n equal to 3. So sine 5 pi x by 2 into sine 2 into 3 minus 1, that is 5. 5 pi x by 2 again. So sine square. So I will get sine square 5 pi x by 2 dx. Now just this is a simple integration. this integral 0. This integral will give the value 1 because I wrote this property. So this is 2 sin square theta means 1 minus cos 2 into 5 pi x by 2, that is 5 pi x dx. So what is that? Sorry. So this integral is, let me write in next page. So 1 minus cos 5x is equal to, integral of 1 is 1 over integral 0 to 1, and cos 5 integration is sin 5 pi x by 5 pi. So integral 0 to 1. So sine 5 pi is 0 and sine 0 is 0. So 1 minus 0, that is equal to 1. So I got a3 equal to 1. So what is then all other an are 0. So let me write an equal to 0 for all n not equal to 3. So what is my w in that case? So w I got here, w x comma t is an this. So all other n not equal to 3 it is 0, except n equal to 3 it has value 1. So w x comma t will give the value only for n equal to 3. So my answer is wx3 equal to a3 sine, I have to put n equal to 3 everywhere and all other are 0. Okay, so let me put n equal to 3. So I got the answer wx comma t equal to a3 equal to 1 into sine 5 pi x by 2 into exponential, I am putting n equal to 3. So exponential what I have? I have 2n minus 1 whole square pi square by 8, pi square by 4 minus. So n equal to 3 means 5 square. 5 square is 25. So minus 25 pi square t by 4. This is my w. This is the answer. So w, let me write in the next line again. Wx comma t is sine 5 pi x by 2 into exponential minus 25 pi square t by 4. Okay, so this is the answer. So let me show you the question. So wx comma t is what? Sine 5 pi x by 2, 6, this option B that I got. Okay, sine 5 pi x by 2 exponential 25 pi square t by 4. That is accepted answer is B also. So my answer is B. You got, let me write answer B. You have any question up to this? Do you have any question? Otherwise, I will move to the next problem. Problem number 9. Do you have any question? No question. Okay. So problem number 9 is that you have to find now u. U is the solution of the initial value problem, not w. You have to find u 1 minus 1 by 4 pi square. Now I have the relation w. I know w. I already find w, and I know w x comma t is u x t minus x minus 1. So I will just find w1. What I have to find in equation number 9 is that I have to find u of 1 comma 1 by 4 pi square. So I will find w of 1 comma 1 by 4 pi square. Then I use that relation to got the value of u. Okay. So I know this relation. We have uxt equal to wxt plus x plus 1. This relation we have. Now I have to find u 1 comma 1 by 4 pi square. That is same as w 1 comma 1 by 4 pi square plus 1 plus 1. I am just putting x equal to 1 and t equal to 1 by 1. T equal to 1 by 4 pi square. Now what is w1 by 1 comma 1 by 4 pi square is, I know wxt equal to this. Sorry, wxt equal to this expression that I put a right. So So w1 comma 1 by 4 pi square is just I have to put x equal to 1 and t equal to 1 by 4 pi square, that is sine pi 5 pi by 2 into exponential 4 pi square I am putting, so minus 25 pi square 1 by 4 pi square by 4 plus 2, 1 plus 1 is 2, so it is equal to sine 5 pi x by 2 into exponential minus 25 by 16 plus 2. This pi square cancel out. Sorry, there is no x. Just to let me use in the expression there is no x, so when mistake I put x. So this is sine 5 pi by 2 this. Now what is now you have to use some calculator, that is what is exponential minus 25 by 16, that will give you the whole expression. The answer is 2.2096. You can use any scientific calculator for that. This is the answer. So 2.2 is the accepted answer. You have to let me show you the answers. The answer is 2.2 I got. Range is 2.1 to 2.3. So 2.2 is the right answer. Okay. So just you have to find W1 by 1 comma 1 by 4 pi square and replace it by u this by that relation. So you got the answer. No need to solve the equation for u again. This just find W. Since I got W, now I use this relation to got u. Okay. So is this clear to you? Question number 9. Question number 9, is this clear to you? Okay, fine. So I will move to question number 10. Let me show you the question. Now here what is showing is that you question is given that u satisfies the heat equation ut minus ux equal to 0, u0t is 0 and u5t equal to 0. That is on the boundary u is 0. Now initially u is hx. So which one of the following function h ensures that uxt is less than or equal to 25 for all x and t in 0, 5 cross 0, 5. So let me first try to write the in the next page. Let me write the question. That is question number 10 is given as ut equal to uxx in the region. So in the region x comma t lies between 0, 5 cross 0, 5. That is a square region, and initially not initially boundary u is given by 0 t is 0 and a 5 comma t equal to 0, where t belongs to this 0, 5 interval, and initially ux comma 0 equal to h of x. So person h, now x belongs to 0, 5. Now again show you the question what is given. Question is saying that which one of the following h ensures that which one of the following function h ensures that u is less than or equal to 25. H are given as this A B C D, four options. So you know how maximum principle of heat equation. Maximum principle of heat equation, you know. Okay, no. Okay, I will tell you. Maximum principle is that is this is my boundary is given 0 and 5. So here it is x equal to 0. Here it is suppose x equal to 5, and here it is t equal to 0. Maximum principle says that the maximum value of u, that is the solution of the heat equation, attains on the boundary these lines, either on x equal to 0 or t equal to 0 or x equal to 5 on this boundary. So you have to find what is the question is that find h such that ux comma t is less than or equal to 25. So maximum value is 25. Now 25 attains on the boundary. Now you have to find those h for which you got the value, maximum value is 25. You have to find those function hx which gives the maximum value 25 at the boundary. Okay. Now not at the boundary, you have to find those function h which gives the maximum value 25. So this maximum value is the maximum value for u, because u x comma 0 is hx, that is the in this line t equal to 0 line, u has the value u x comma 0 equal to hx. Now we have to find those function hx which gives the maximum value as 25. So option A is given hx equal to, you have to check by options, hx equal to 4x into 5 minus 6, right? So how to find the maximum value? You have to just differentiate this thing. Let me write hx again. It is 20x minus 4x square. So h dash x we have to find, and h dash x you have to put equal to 0, and h double prime x you have to find. Then you have to show that h double prime x is negative. So this is 20 minus 8x. So h dash x equal to 0 gives 20 minus 8x equal to 0. That gives x equal to 20 by 8, that is 10 by 4, that is 5 by 2. So that is 2.5. Now h double prime x is minus 8. Minus 8. That means h double prime 2.5 is also minus 8, which is negative. So h has the maximum. Hx has maximum at x equal to 2.5. So what is h of 2.5? What is the maximum value? That is, sorry, hx equal to 20x minus 4x square. 20 into 2.5, 2.5 means, let me write 5 by 2 minus 4 into 5 by 2 whole square. So that is 50 minus 25. So equal to 25. So h attains, for the option A, h attains its maximum value 25 at x equal to 2.5. Now maximum principle says, what maximum principle says, let me write. Maximum principle for heat equation says that maximum value attains on the boundary. Maximum value of solution u attains at the boundaries only. So here boundaries are, x equal to 0, x equal to 5, and t equal to 0. Here for the option A, maximum value attains at t equal to 0, that is 25, and I have to find those h such that uxt less than or equal to 25. So my option A is correct because it attains its maximum value. So option A is correct. Now option B. What is option B given? Option B is given as hx equal to 26 sine 5 by x. But 26 sine 5 by x is always less than or equal to 26, right? Because sine 5 pi has maximum value 1. So this is always less than or equal to 26. So it does not have 26 value attained at x equal to, say, some pi by 2, x equal to half, and 5 pi by 2 is 1. So, and the value 26 is attained. So So I got that maximum value is attained. So 25 is not the maximum value. So in that case, option B is false. So B is false, not correct. Because I have to find uxt less than or equal to 25, but I am getting here 26. So it is not possible, not the correct option. Option C is given hx equal to 3x square into 5 minus x. So that is equal to 15x square minus 3x cube. So what is h dash? Same procedure you have to apply. H dash x is 30x minus 9x square. Now h dash x equal to 0. I got 30x minus 9x square is 0. So I will take x common. It is 30 minus 9x equal to 0. So two are possibilities, either x equal to 0 or 9x x equal to 30 by 9, that is 10 by 3. These are the two. Now what is h double prime x? That is equal to 30 minus 18x. But h double prime 0 is given 30, which is positive. Positive means it gives minimum value. It is giving minimum, but we are interested in maximum here in this problem. So h 0 is not our uh, feasible point. We have to find h double prime 10 by 3. That is 30 minus 18 into 10 by 3, that is 30 minus 60, it is minus 30, negative. That means it gives maximum. So our point is 10 by 3. Now what is value at 10 by 3? That is h at 10 by 3 is h at 10 by 3. What is h? H is 15x square minus 3x cube. So 15 into 10 by 3 whole square minus 10 by 3 whole cube. So that is equal to 15 into 100 by 9 minus 10 into 1000 by 27. I think it is 3x square. Oh, sorry, 3x cube. I am writing 10x cube. Sorry. So let me just erase this 10 by. I have to replace it by 3. So it is 3 into 10 by 3 whole cube into 3 into 1000 by 27. So that is equal to everything cancel out here. Oh, sorry, here 9. So 1500 minus 1000. So it is 500 by 9. That gives you the value approximately 55 point something, 55. Okay, so here, so what is that? H of 10 by 3. We have one maximum is our maximum range is 25, but I got h of 10 by 3 55 point something, which is greater than 25. So option C is also false. Now option D. Option D is given root over 3x into 25 minus x square. Option D is, I have to find by 25 only. Hx equal to root over 3x into 25 minus x square. So again I have to find the differentiation and putting it equal to 0. So h dash x is root 3 into 25 minus root 3 into 3 into x square. So h dash x equal to 0 gives my x square equal to 25 by 3. Okay, that is easy. Root 3 cancel out. So I got x equal to plus minus 5 by root 3. Now I have to find which gives positive negative value. H double prime x is minus 3 root 3 into 2x. So h of double prime plus 5 by root 3, that gives me minus 6 root 3 into 5 by root 3, that is minus 30. So that gives you negative, that means maximum. So I will consider only 5 by root 3 part. So I have now I will find the value of h at 5 by root 3 and so if it gives 25 or not. If it is greater than 25, then option D is also false. Now h 5 by root 3 is root h is what? H is hx equal to root 3x into 25 minus x square. So h 5 by root 3 is root 3 into 5 by root 3 into 25 minus 25 by 3. 5 into 25 minus 25 by 3, that is 5 into 50 by 3, that is 250 by 3. So this also gives greater than 25. So it is not, option D is also false because we have to find what we have to find. We have to find those h such that uxt less than or equal to 25. Only option A gives the correct. Option A, B, C, D are false. Option D, option D is false. Okay, so option A is the correct option. Is it clear to you? Okay, so I'll move to next two questions are left. So that's the easy question. Same, you have to use maximum principle. Very easy. So question number 11 is that there's two questions left. So question number 11 is U be the solution of the initial boundary value problem. Homogeneous heat equation ut minus ux is 0, u0t is sin x, u1t cos t minus 1 and ux comma 0 is equal to x into 1 minus x. So what is the maximum value of u in 0 1 close interval cross 0 infinity? So let me write the equation. Then so number 11 is that u satisfies ut minus uxx equal to 0 equal to 0, u0 boundary, u0t is sin t and u1t is equal to cos of t minus 1 and u x comma 0 equal to x into 1 minus x. This is my boundary. This is x equal to 0, this is x equal to 1 and this is t equal to 0 initially. So you have to find the maximum value of u. So by maximum principle for heat equation, by maximum principle, maximum attends, maximum of u attends at the boundaries. At the boundaries only. So what is the maximum of u? What is the maximum of sin t? At the boundaries you have value of u as sin t, cos t minus 1 and x into 1 minus x. So maximum of sin t is plus 1. Sin t maximum value is 1. Maximum of cos t minus 1. Maximum of cos t minus 1 is what? You know maximum of cos t is also equal to 1. So cos t maximum is 1 and 1 is a constant. So 1 minus 1 is 0. And what is maximum of x into 1 minus x? That is turns out to be 1 by 4. How? You have to again use the same condition, that is you have to again use what? You have to use that suppose fx equal to x into 1 minus x. Let then what is f dash x? F dash x equal to x 1 minus 2x. So f dash x equal to 0 gives x equal to half, right? So what is f double prime x? Here I write f double prime x is minus 2. So what is f double prime half is also minus 2, that is negative. So we have maximum value. So maximum value is f of half is the maximum value, that is half into 1 minus half. Half into half 1 by 4. That's how I got maximum value. So now maximum value of u attains at the boundaries. So maximum value of sin t is 1, maximum value of cos t minus 1 is 0, and 1 by 4, maximum of x into 1 minus x is 1 by 4. So what is the most maximum among these three things is 1, right? 1, 0 and 1 by 4. So most maximum is 1. So answer is 1. So maximum of u is equal to 1. This is my answer. So let me show you again. Maximum of u is 1. Accepted answer is also 1. Now you have to the same question. You have to find the minimum of u. Okay, you have any question from question number 11? You have any question or not? Otherwise, I will move to question number 12. That is the last question. No. Okay, fine. 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 Question number 12 is that the same thing. Minimum value also attains on the boundaries. Now you have to find minimum of those sin t, cos t minus 1 and x into 1 minus x. So let me just write. Let me write that this thing that for heat equation, minimum value of solution also attains at the boundary. Minimum value of solution u attains at the boundaries. So here here boundaries values are given by sin t, cos t minus 1 and x into 1 minus x. Same equation, same question. So what is the minimum value of sin t? Minimum value of sin t is minus 1. Minimum value of sin t, that is minus 1. Minimum value of cos t minus 1 is what? Can you tell? Just ask you one question just at the last. What is the minimum of cos t minus 1? Can you tell? Otherwise I will tell, no need to worry. Minimum value of cos t is what? Minus 1, right? What I find here, maximum of cos t minus 1 is, maximum of cos t is 1. So cos t minus 1 maximum value is 1 minus 1, 0. Here minimum value of sin t is minus 1. Minimum value of cos t is also minus 1, right? So minimum value of cos t minus 1 is minus 1 minus 1, that is minus 2. And minimum value of x into 1 minus x, that is 0, because it is equal to 0 because x lies between close interval 0 1, right? And x, that means x greater equal to 0, and 1 minus x also greater equal to 0, since x lies between close interval 0 1. So what is x into 1 minus x? It is always greater than or equal to 0. X greater than or equal to 0, 1 minus x also greater than or equal to 0. So x into 1 minus x product greater than or equal to 0. So minimum value of x into 1 minus x equal to 0. So what are the most minimum among these three? Minus 1, minus 2 and 0. The most minimum is minus 2. So minimum value, my answer is minimum value of ux comma t is attains on the boundary, and on the boundary the most minimum is minus 2. So minimum value is minus 2. This is my answer. Let me show you. Accepted answer is minus 2. So this is the minimum. Since minimum also attains on the boundary. So if these questions are over, okay, you have one question is that, is this any effect on solution when boundary condition is changed? No, actually no effect on the solution, because maximum minimum value attains on the boundary only, and if you change the boundary condition, that means you are changing this function sin t cos t minus 1 and x into 1 minus this. If you are changing, then your maximum minimum value also change. Here the maximum principle says that for heat equation maximum and minimum value attains on the boundaries, and if you change the equation, then it will affect on the maximum and minimum value of the solution. Is this any effect on solution when the boundary condition is changed? Yes, it will affect. If you change the boundary condition something else which has different maximum and minimum value, then the maximum minimum value of the solution also changes. The answer is yes of your question. Any question? Okay, how? Okay, I'll show you. Maximum the functions. Okay, so how? Your question is how? So let me write in one page. That suppose the suppose equation is same upt minus ux6 equal to 0. But you are changing your condition. That is, here your condition is, here my condition was u0 comma t equal to sin t. So let me write sin t by some other function. Let let 1 minus t square, something like that. Okay, so what is and 1 minus t square will be, yeah, yeah, yes, that is okay. And suppose u1 comma t you are giving as 0, and ux comma 0 you are also giving as 0 for simplicity. I mean, just again. So what is 1 minus, you are changing, that means you are changing the conditions on the initial and boundary. So what is the maximum of 1 minus t square? So 1 minus, suppose h of t equal to 1 minus t square, h of t, and h prime of t is what? H test is minus 2t, fine, and h double prime t equal to minus 2. So it is always negative. When now h test t equal to 0 gives you minus 2t equal to 0, so t equal to 0. So your h has maximum at t equal to 0. So what is the maximum? Maximum is h of 0, that is 1. So here if you change the condition, your maximum become 1. Okay, same as minimum. You have to construct some different functions for that. Please give me one example. That I give you. If you change the, if you change this this condition, initial and boundary condition, you got maximum value 1. But suppose I change it by this half t square. Okay. Okay, not here half. I just write it half minus t square. Okay, so what I got, h of t equal to half minus t square. So same thing, but I will got h0 equal to half. We'll check just, because derivative is minus 2t, minus 2t equal to 0 means t equal to 0, and h double prime at 0 is minus 2. It is always negative, so h gives maximum at t equal to 0, and h of 0 is half. So I got half, maximum of 1 half, sorry, maximum of half minus t square is half, and here maximum is 0, here it is 0. So all the, between among all these three, the most maximum is half. So my answer is half. So the solution changes as you change the conditions. Is this, but here the function is changed. What is your question? Is this any effect on the solution when boundary condition is, yeah, boundary condition change means function is changing, right? Or what you want to say, that 0 and 1 these are changing? function is changing, yes. Your question is that is this any effect on solution when the boundary condition is changed? Boundary condition is changed, that I means that the function are changing. If you want to say that I want to put u0t and u2 comma t, something like that, then there is no effect on the solution, because it does not it does not depends on the boundary where the boundaries are. It depends on the functions that are defined on the boundary. Just check it. Let me write in the chat box. It does not depend on where the boundaries are, but depends on the functions depends on the function that are defined on the boundaries. That is I think gives the answer. It the solution, the maximum or minimum, it means the either the maximum or the minimum. That does not depend on where the boundaries are, but it depends on the functions that are defined on the boundaries. That I think that gives you your the answer to your questions. Okay, is there any you have another other question? Thanks. Okay, thanks for joining. uh, oh, no question. Okay, thank you. So today is my last class of NPTEL. So thank you for attending my classes. Thank you very much. So you can leave now if you have no question. Thank you. If you have any question, you can ask. Otherwise, you can leave the meeting.